Good day, ladies and gentlemen, personalities. Today we are going to do the trigonometry part of November 2020 exam. Can you see here? This is November 2020 exam, but we are only going to do the trigonometry part. So we're going to start from question 5. Right. So I want to say it, ladies and gentlemen, personalities, that the memo for this paper is already available on the website. You can always go and check it, but the difference is that here you've got a person explaining things and then also explaining where do they come from, of which sometimes the memo falls short into explaining. But one other thing that is very important that I think I need to mention, guys, is that okay, first of all, I do not know in which level are you or what you have done so far, but if you haven't done any work, I do not suggest that you start with doing this, watching this video. So what you can simply do is to go through this channel and then take and go, there's a folder there in this group, because you've got like different topics most, and then each topic has different lessons. You can go to the to the topic of trigonometry, and then you can just go through some lessons there and then be all right there. And then after that, you can then take this paper, okay, take your own paper, because it's available in the Department of Education. Take a paper like this one and then try and do it on your own first, right? Try and do it on your own first. Now after doing it on your own, then you can come back and then check how we've done answers there, and then you can check if your answer are the same as our answer, and then you can take things from there, right? Wonderful. Okay, because if you just start right away and then you start looking at this at this memo, then it won't really help you much, right? By the way, my name is Mqondisi Macaba from Thembela Maths Club, a club that helps learners to understand mathematics. Ladies and gentlemen, personalities, if you want to become part of this community, you can go ahead and click the subscribe button down there. There's a subscribe button down there, and then if you want to be informed when another video is posted of this kind, because I'll be posting a lot of videos, both paper 1 and paper 2. So if you want to be notified, click the notification button as well, so that when I post these videos, you will be notified. All right, wonderful, lovely. Okay, ladies and gentlemen, without further ado, let's continue and see what we can do here. All right, question 5. They say the graph of f at x. Okay, so this is question 5. Question 5, and then they say f at x is equal to this. Okay, you must just write it down. F at x is equal to minus 1 over 2. Why am I writing this thing down? I'm writing it down because I know I may need it somehow. So, okay, and then g at x, they say g at x is what? It is equal to sine, and then it's x plus 30 degrees, and then they say the interval is x is an element of 0 degrees up to 180 degrees. Okay, and then they say this point, which is a 130 degrees 0.9, so a 130.9 degrees versus 0.33. They say it is what? It is a point of intersection, right? So that is where these two graphs meet. Okay, so I'm writing this information so that I just extract it, and then so that I can use it when I need it. Okay, ladies and gentlemen, personalities, they say okay, you wait, during the exam you don't necessarily have to write it down like this, but if you want to, you can. Okay, now this is the information that you have been given, and then this is a graph that corresponds to it. All right, now let's go to the questions. Question number 1, 5.1. They say find the period of G. Let's look at 5.1. Now where is G? Let's start with the G is G at x is equal to sine x plus 30 degrees. Okay, now ladies and gentlemen, on the side, how do you find the period of any trigonometric function. If you have y, which is equal to a sine bx, now the period here is always 360 degrees divided by b, whatever the value of b here. All right, so here p is going to be 360 as well, and then divided by b. What is b of this one? B is a coefficient of x. What is the coefficient of x? Coefficient of x is 1. So divided by 1, which is equal to 360 degrees. So the period there is 360 degrees. So here is your 1 mark. Okay, 5.2, let's go on. 5.2, determine the value of f at 180 minus g at 180. Okay, so we'll just say f at 180 degrees minus g at 180 degrees as well. Now what is our value of f? Here is our f. So we've got minus 1 over 2, and then cos, in the place of x, what do we put? We put 180 degrees, and then minus our g. What is our g? Our g is sine, and then in the place of x, what do we put? 180 degrees plus 30. Okay, now ladies and gentlemen, personalities, we can just put these things exactly like this in a calculator. That wouldn't give us any problem, right? So basically you can just put it like this, and then when you put this thing in a calculator, you will sort of come up with, but just to show your steps and whatever that you are doing, you can look at cos 180. What is cos 180 on a calculator? Cos 180 is nothing other than minus 1. Okay, so you have minus 1 over 2 times minus 1 minus, and then cos 180 plus 90. So sorry, sine 180 plus 90, sine 180 plus 90, sorry, not plus 90, plus 30. And then what you get? You get minus half. You get minus half. Okay, so this times this, minus half times minus 1, you get what? You get half. And then this minus and this minus, they turn into positive. 1 plus half, and then that gives you what? Half plus half is what? Half plus half is equal to 1, right? So here's your mark. You got your 1. All right, let's go to the next part. And then they say, oh, okay, can you see? I was just showing you guys. You see there is 1 mark here, right? So if it's 1 mark, you can just put this thing as it is, literally as it is, because you don't necessarily have to do all of these things. I was just showing you how you get it done. You can just put it literally as it is in a calculator, and then you get 1, and then just put 1, because you've been given what? You've been given 1 mark. You must watch the marks as well. Okay, the marks indicate something in terms of the expectation of what you should write. Okay, right. Now let's go to the next one. Let's look at 5.4.1. Okay, 5.4.1. What do they say? They say use the graphs to determine the value of x in the interval of x, that's an element of 0 degrees to 280 degrees, for which f at x minus 10 degrees is equal to g at x minus 10 degrees. Okay, so what you're simply doing here is you are shifting both the graph of f at x and the graph of y of g at x. You are shifting it by minus 10. Remember, if you say minus 10, that means you are shifting it 10 degrees. Where? 10 degrees to the right. Okay, because remember, if you take a graph and you say x minus, say a, therefore that means you are shifting this graph, whatever it is, a unit where? To the right. Okay, so you are doing this exactly the same here. So now Now there's a point of intersection here. That is the point of f at x is equal to f at is equal to g at x. And then this point is this one, which is 130 degrees. Now remember, the only thing that is going to shift there is the x, is not the y. Okay, so when you shift, what is the value of x that's going to be? So it's only the value of x. So you just take this value of x and what you do to it, and then you add 10 degrees. So it was 130,9. So when you add 10 degrees, what happens to it? It's going to become, so you say therefore x is going to be what? It's going to be 140,9 degrees. All right, there you go. And then lastly, so you look at this was like this, and then what you did there is you shifted it 10 degrees to the right. So when you do that, you add to whatever number this is, you add what? 10 degrees, and then this is how you get this one. All right, lastly, the last one, that is 5.4.2. okay, so what you have here, you've got root of 3 sine x plus cos x is greater or equal to what? Is greater or equal to 1. Okay, so how are you going to look at this? So you've got root of 3 sine x, and you can't compare it to anything here. Okay, that's another problem. And then you've got cos x. Okay, and then also there is cos x here, but there is half, and here there is nothing. Okay, and then it's greater than 1. So you are looking for the values for which this part is greater than 1. And it's very difficult to reference this thing here because these two things are not the same as whatever that you can get here. Okay, so what we'll have to do on our side is to actually try to manipulate this using mathematical methods so that we can be able to find something that relates to somehow either one of these graph or both of them, so that we can see how those shifts happen. Okay, so what can we do? Okay, one of the things that we can do, okay, I can see x here. We can easily divide by 2 here. Can you see that? We can easily divide by 2 and then we can get half. But now, because this is a sort of an equation, I cannot divide by 2 here and then leave here and leave here. So if I divide by 2 here, I must also divide by 2 here and also divide by 2 here. Alright? So if I do that, I will then do this 2 divided by 2 and divide by 2. And then I will end up with what? With root 3 over 2 sine x. Now plus half cos x, and then it's greater than equal to, when I divide by 2 here as well, I'm going to have 1 over 2. Alright? Okay, 1 over 2. Now, if I remember from my triangles, if you have something like this, remember you've got 60 degrees and then 30 degrees, and then you had 1, you had 2, you got root 3. When you have root 3 over 2, it will be what? It will be cos of what? It will be cos of 30, because cos 30 is, cos is adjacent, which is root 3 over hypotenuse. Can you see? So cos 30 is same as root 3 over 2. So this is same as cos 30. Okay, what am I trying to do? I'm trying to play around with this so that it resembles any of these things, so that I can be able to look at it here and be able to answer questions that I need to answer. All right, so now in the place of this, I have what? I have cos 30 degrees. Okay, and then I have sine x, and then what do you know about half? Half as well, it's opposite over hypotenuse, that is sine. So it's plus, and then I've got sine 30 degrees and then cos x, which is greater or equal to, let me leave my half like this. Okay. Okay, so now this is what we have. Remember, what do I want to do? I want to find something that looks like some of these things, either this one or both or whatever, but it must be close to these things. Okay, so how am I going to do it? Okay, now if I see this, it's cosine and then sine cos. I must go and look at my formula sheet. When I have sine and cos and sine, what do I have? Let's see. What is it? Cos, sine. Let us see. Okay. Cos, sine. Okay, there we go. There is cos and then sine and then cos and, oh, you've got sine and cos. Let me see. You've got cos, sine, sine and cos. Okay. So, and then, so we've got plus here. And then also we've got cos. So that is basically sine what? Sine A plus beta. Can you see that? All right. So when you look at this thing, it's going to be, okay, it's going to, this is like, okay, where can I put this thing? This is like cos A, ne, sine B, and then plus sine A cos B. Okay, and then when you've got cos A sine B and sine A cos B, that is nothing other than what? It is nothing in terms of this formula. Then you have sine A plus beta. So sine A plus B. Okay, so just put this in a circle, and then so it means that through this you will end up having, this is same as sine what? Sine 30 degrees. 30 degrees, right? 30 degrees plus x, okay, which is greater than, equal to half. This is same as sine x, you just swap things around, plus 30 degrees, which is greater than 1/2. Okay, so you've got sine 30 degrees, which is greater than 1/2. So now this is something that you can actually work with. Okay, so it's something that you can actually work with. So when you've got sine x, okay, it's greater or equal to, so if you take the equal part, you will know that you will remain with x plus 30 degrees, which is equal to the reciprocal of sine 1/2, right? Yes, you are going to do that. So when you get the reciprocals of sine, which is equal to 1/2, you're gonna get x plus 30 degrees is equal to what? This will give you sine, this will give you 30 degrees. You can put this on a calculator, you will see you will get 30 degrees. Okay, and then so when you take this 30 to the side, you can get x, which is equal to 0. So now this is a reference angle. Okay, so your reference angle is x is equal to 0. Okay, but here you were looking for the sine of a trigonometric function that is equal to 1/2, a number that is positive. So sine is positive in which quadrant? There are two quadrants where sine is positive. And where is that? It is in the first and what? First and and second quadrant. Okay, this is first and second quadrant. Okay guys, there is a mistake that we did here. This is not the reference angle. The reference angle is this one. Okay, so the reference angle is this one. It's x plus 30 degrees. Remember guys, okay, let me just put it here so that you can see. So remember, you've got sine theta, which is equal to say b. Okay, so whatever that is here, that is what constitutes what? A reference angle. So now in this particular case, our theta is x plus what? Plus 30 degrees. So that's what makes a reference angle. So a reference angle is x plus 30 degrees is equal to this 30 degrees. Okay, yes, let's cancel this one. And then what we do now is that we must then now note that since we have sine of this angle, whatever angle it is, which is equal to something that is positive, we know that sine is positive where? In the first quadrant and the third quadrant. Now, so now in the first quadrant, you've got x plus 30 degrees, which is this one, right? Now, being equal to just the angle as it is, which is 30 degrees. Can you see that? Yes, can you see? It's 30 degrees. And then so when you take this 30 to this side, you will then have x is equal to 30 minus 30, which is equal to 0 degrees. Okay, so you've got x which is equal to 0 degrees. That is in the first quadrant. Okay, now what happens in a second quadrant? In the second quadrant, you've got the same thing. You've got x plus 130 degrees, sorry, not 130, 30 degrees being equal to, but now it's no longer equal to 30, is equal to 180 minus what? Minus 30 degrees, right? So what is 180 minus 30? So you get 150 degrees. Can you see that? So x plus 30 degrees is equal to 150 degrees. Now when you take this 30 to this side, it's gonna be what? It's gonna have x alone here, and then 150 degrees minus 30 degrees, that's just going to give you what? It's going to give you 120 degrees. All right. Right, so listen to the personal analysis. To check if these answers are right, you must take these numbers and add them here. So if you take this 0 and then you put it here, it's going to be 30 plus 0, which is sine 30, which will give you half, which is exactly this. And then if you put this 120, it's going to be 120 plus 30, which is 150, and then sine 150 is going to give you half. Right, so because of that, therefore this x that you are looking for is in the element of what? In the element of between 0 degrees and what? And then 120 degrees. And then you close it. Alright, now that was question 5. Now let's go to the next question, which is question 6, and let's see how things go there. Right, question 6. Guys, if you have further questions regarding this, please do not hesitate to ask. There's a comment section below where you can always ask, and I'm always ready to answer your questions. Right, so question 6, let's look at question 6 and let's look at how things go there, and then let's take it from there. Okay, so you are given a diagram here. In question 6, they say in the diagram we've got point P. Okay, here's point P, we can see it, and then and then T lies on the positive x-axis. Where's T? Here is a point T. Can you see it? So here is point T. And then they have POT, which is this. They say it is equal to theta. All right. And then the first question is that answer the following without using a calculator. So you can't use a calculator for this one. Okay. So the first one is find the value of tan theta. Ladies and gentlemen, we know that tan theta is equal to y over x. Okay. Is equal to y over x. So in this particular case, question 6, question 6. So in 6 point, okay, before you even get to 6.1, okay, yeah, in 6.1, what do we have? You've got x. Remember, you've got x here, which was what? -5, and then y, which is 12. Okay, so the one value of tan theta is always equal to y over x, which is equal to what? Which is equal to 12 over -5. But obviously, we know that whenever we have a minus, we always put it here. So -12 over 5. So that was our 6.1.1. Right? Okay, what is 6.1.2? 6.1.2, they are saying you must calculate the value of cos theta. Okay, cos theta, 6.1.2. Okay, the cos theta, you know, cos theta is x over r. We've got x here, we don't have r. Can you see that? So how can we find r? We'll use what? You will use Pythagoras. And then what do you say? You will say r squared is equal to x squared plus y squared. What is our y squared? Is -5 squared plus what? There is 12 squared. Okay, remember they say we mustn't use a calculator, so you can't use a calculator with this one. Okay, so -5 squared, that is 5 squared is 25. It's 25, and then 12 squared is 144 plus 144. 25 plus 144, what is it? It's 160. 160. Now guys, you must learn how to count with using your head. Okay, so this is r squared, which is 169, and then you've got r, which is plus or minus square root of 169. What is square root of 169, guys? We know it's 13, so it's plus or minus 13. But guys, we know that we're looking for r, and what is r? R is a radius, and radius is always positive, so therefore r is equal to 13. Okay, so now when we want cos theta, it is equal to x over r, so it's going to be what? It's going to be -5 over 13. That is our 3 marks. Right? Does it make sense? Alright, let's go to the next question. And this question is 6.1.3. Okay, so what do they say here? They say S A versus B is a point in the third quadrant. Okay, so they now say we've got a point where? In the third quadrant. Remember, we already had a point here. Let's just quickly write this one. See, we had this one. We had P, and then that P, the x there is -5, right? And then the y is 12. Okay, so this P, okay, it was like this. Okay, never mind my writing. So we've got y, you've got x. And then now they say, what do they say now? They say you now have SAB, which is a point in the third quadrant. Okay, so this point is somewhere here. And then you've got TOS. So TOS, So this point is here. Let's say this point is here. It's S, and then it says A that we do not know what it is, and then it says B that we also do not know what it is. But what we know is that TOS. So if you draw this point like this, therefore the angle, remember T was here. So if you calculate an angle from here to here, it will be what? It will be theta plus 90 degrees. Okay. So what you'll simply do is that here you will put theta plus 90 degrees. Can you see that? Okay. It's theta plus 90 degrees. Okay. And then what else do they say? And then OS is 6.5 units. So here is O. So OS is 6.5. So here you've got 6.5 units. Can you see that? Okay. And then they say calculate the value of B. Now what is B? B is the Y part of this. So it's the distance between here and here. So what you will simply do is that you will put your B here. Okay. Remember, so you are looking for B, and this is what you've got, and then this is the angle that you are using. Okay. So in order to find a formula that can actually work here, you must include what you are given and what you are looking for. You must find something that can combine those two. Okay. So in this particular case, you need a sine of this thing. So it's sine of this angle. What is this angle? This angle is theta plus 90 degrees. Can you see that? Okay. And then it is equal to opposite. What is opposite? It's B. It's B over hypotenuse. Hypotenuse is 6.5. Right. Can you see that? All right. Now, I want you to hold on to fasten your seatbelt. Now, there is 90 degrees. Can you see that? There is 90 degrees. So when it's 90 degrees, you know that we shift a trigonometric function into a co-function. So this was sine, and then this will become what? This will become cos. So you're going to have cos of theta. And then now we must look at the quadrant. Theta plus 90 is which quadrant? It is the second quadrant. And then how is sine in the second quadrant? Sine is positive, so you're going to leave it like this. It's going to be cos theta. And then this is going to be equal to B over 6.5. Okay, ladies and gentlemen, you already have cos theta. Cos theta is this. Can you see that from above? So you're going to take this cos theta as it is and use it. We can say minus 5 over 13 is equal to B over 6.5 degrees. Okay. And then obviously, when you are here, you can see that what you will need to do is to just, you need B to be alone because this is what you are looking for. So you're going to multiply by 6.5, and then also here you're going to multiply by 6.5, and then this 6.5 will cancel this one, and then you will remain with B here. And then when you put this in a calculator exactly like this, okay, then what is it that is going to happen? Then you are going to come up with 2.5, right? So you're going to come with minus 2.5. So B that you are looking for is equal to what? Minus 2.5 units. Okay, remember, because this is a distance. Now, does this correspond? B, they say it's negative. Remember, we said B is a value of y, and then the y that is here, we all see that it's a negative y. So that means it does correspond with what we are supposed to do, right? Number 1. So the next question is 6.2. Let's continue with 6.2. Now, what is happening in 6.2? They are saying determine without using calculator the value of the following trigonometric function. Okay, now let us continue and see. So what do we have? We have sine 2x, right? And then cos minus x plus what? Plus cos what? Cos 2x, and then times sine 360 degrees minus x. All of this divided by what? Divided by sine 180 degrees plus x. Okay. So what do we then do? Guys, we know that once we have sine 2x, we know from double angle formulas, this is same as 2 sine x, what? Cos x. Can you see that? Right? And then remember, cos x and cos minus x is the same thing. So cos minus x is same as what? It's same as cos x. Okay? Right. And then plus, now you've got what? You've got cos 2x. Now cos 2x, guys, there are 3 identities. Okay? So the first identity is cos squared x minus sine squared x. And then the other identity is what? Is 2 cos squared x minus 1. And then the other identity is 1 minus cos. It's 1 minus 2 sine squared x. Okay? So you must choose which one you are going to take. So which one are you going to take? So it must always be in line with what you are trying to do. Okay, so you can see that here we've got, okay, 2 sine x cos x. Okay, so from this one you can see we're going to have what? We're going to have cos squared x. Okay, so you're going to have cos squared x here. So if you have cos squared x here, you might as well try to find something that has sine squared x on the side, so that you can see what you can do. Okay, and then you can just take things from there. All right, and then we'll see. So in a place of cos, what we're going to do, we're going to put 1 minus what? Minus 2 what? 2 sine squared x. Okay, and then let's enter personalities. Here we've got sine, so we've got sine 360 minus x. So sine 360 minus x, what do we know about it? 360 minus, that is this is same as sine x, right? It's same as sine x. And then which quadrant is this? It is the 4th quadrant. Why? How is sine in the 4th quadrant? Sine in the 4th quadrant is minus, so it's minus sine x. Okay, and then let's look at down here, sine 180 plus. 180 plus, which quadrant is that? The 3rd quadrant. So this is going to be sine x, but in a 3rd quadrant, sine x is what? Sine x is minus. All right, so that is what we are going to remain with. All right, okay, and then what are we going to do about this whole thing? So remember that if you have a plus b divided by c, this is same as what? This is same as a over c plus what? Plus b over c. So in the same way, this is same as 2 sine x. Okay, let's already put cos squared x here. And then here and then say divide by minus sine x. Okay, remember this is rough work on the side, and then plus, let's keep this like this, and then we have 1 minus 2 sine squared x multiplied by minus sine x, all divided by minus sine x. Can you see? So this will cancel this one, can you see that? And then this will cancel this one, but there is minus, so minus will go up. So what is going to happen? You're going to end up with minus 2 cos squared x, right, plus 1 minus 2 sine squared x. Okay, and then you can just put these two together, because you can see there's a pattern that is playing out. So you can have minus 2 cos squared x minus 2 sine squared x plus 1. So you just rearrange these things. So here you can see between these two there is a common factor of minus 2, and then you can say minus 2 and then open bracket and say cos squared x, right, minus sine squared x, and then plus 1. Can you see that? Now if you've got cos squared x minus 2 sine squared x, this is what? This is cos 2x. So you end up having minus 2 cos 2x, going back to that identity, plus 1. But when you are here, there is nothing else that you can do, so you need to just leave it like this. This is the simplest possible form. It was this mixed match, and now you are ending up with something more simpler, which is none other than this one. All right, so you have managed to do what? You have managed to simplify your equation. Okay, this was 6.2 of November 2020. Right, now let's go to the next one. All right, now whenever you finish something as a mathematician, make sure that you check it if it's all right. Okay, now let's quickly check here if things are all right. Okay, so we're here, and then so what we did, okay, from here to here it's minus 2. Okay, if I multiply this, I must get this one. Okay, if I multiply this in this, I do get this one. Guys, there is a problem. Can you see? If I multiply this with this one, I don't get this one. Can you see? So this one is supposed to be plus. Sorry for that mistake. So that one is supposed to be plus. So cos squared plus sine x then becomes, now it doesn't become 2x. What does it become? It becomes 1. Can you see? So minus 2 times 1. Now what do you get? You get minus 2 plus 1. And then what is your answer? Your answer is minus 1. So basically our answer here is not that something that has 2x, but it is what? It is nothing other than minus 1. All right, now let's go to the next question. Okay, sorry for that mistake, guys. We make mistakes, as I said, in maths. Even teachers, they do make mistakes. All right, so glad we corrected it. So let's continue. Now 6.3, what is happening in 6.3? They are saying find the general solution. You've got 6 sine squared x plus 7 cos x minus 3 is equal to 0. And then they say find the general solution. So how do you find the general solution, guys? You've got cos and sine. You can't change this cos because it's not squared, but you can change what? You can change sine squared to be something that is cos. And then you all know that Sine squared is same as what? So you've got 6. This is the same as 1. Remember, there's an identity that says that sine squared plus sine squared x plus cos squared x is equal to 1. So if you have sine as the subset of formula, you can take this cos to this side. So you end up with 1 minus cos squared x, right? Which is going to be, and then okay, this is just side work. Okay, plus 7 cos x minus 3 is equal to 0. Okay, so 6 times this, we're going to have 6 times this, and then minus 6 cos squared what? X plus 7 cos x minus 3 equal to 0. Now 6 minus 3. What is 6 minus 3? Ladies and gentlemen, 6 minus 3 is nothing other than 3. Okay, so you will end up having minus 6 cos squared x plus 7 cos x minus 3 is equal to 0. Right? Now when you've got this thing, guys, you know you can use a K method. So you're gonna let cos x be equal to K. Okay, so if cos x is equal to K, then you know that you're now having minus 6k squared plus 7k minus 3 equal to 0. Okay, now when you are here, you can then find the value of k using the quadratic formula. Now what does quadratic formula says? So you've got k, which is equal to minus b plus or minus square root of what? Square root of b squared minus 4ac all over 2a, right? So in this particular case, what is it that you have? You have nothing other than, so you've got equal to minus 7, because there's a 7 here, and then plus or minus square root, and in the place of b you have 7 squared minus 4. In the place of a you've got what? Minus 6, right? And then careful guys, 6 minus 3 is positive 3, not negative 3. Okay, so here is also positive 3. Sorry for that mistake. And then so you've got positive, so a you've got minus 6, yes, minus 6, and then c you've got positive 3. Okay, all over 2a, and then in the place of a you've got your minus 6. Okay, now ladies and gentlemen, you can put this thing straight as it is in a calculator, and then when you put this thing in calculator, you are going to get k, which is equal to 3 over 2, or k, which is equal to minus 1 over 3. But remember, this k was cos x, so because of that, so you say but k is equal to cos x. So because of that, cos x is equal to 3 over 2, right? Or cos x is equal to minus 1 over 3. Okay, right? So you then have to find a reference angle, and then if you have cos x, which is equal to the reciprocal of cos, evaluated at 3 over 2, when you put this in a calculator, what you get undefined, so there is no solution here. in this part. Okay, but here remember you can't put this minus. You're going to take just x is equal to the reciprocal of cos evaluated at 1 over 3. And then what is it that you then get? Then what you're going to get here, put in your calculator, you can check it, you can get 70, comma what? Comma 5, 3 degrees. Okay, so remember you had cos x is equal to minus 1 over 2, so it was a minus number here. So cos is minus where? Its cos is minus in the first and which quadrant? And then it is also in the third quadrant. Okay, so you're gonna have two sets of solution, one in the first quadrant and one in the third quadrant. Let's start with the first quadrant. Sorry, not first, third. So third and I'm talking nonsense, guys. Sorry, it's second and third quadrant. So let's look at the second quadrant solution where cos is negative. So second quadrant, you always know you've got theta is equal to 180 degrees minus what? Minus 70,53 all plus 360 n. Okay, so what is that? 180 minus 70, 3 is going to be nothing other than 109 is equal to 109, 47 plus 360 n. Okay, and then this is the second quadrant. What about the third? Let's quickly write the third quadrant here. In the third quadrant, we know third quadrant is what? Is 360 minus. So theta is equal to, it's not 360 minus, it's 180 plus. Is 180 degrees plus this reference angle that we have, which is 70,53 degrees plus 360 n. Okay, now 180 plus 70, 70, what is that? You're going to get 250. So theta is equal to 250. Guys, don't write like me. I'm writing here because I'm running out of space, but on normal cases I would have written on the next page. Okay, so basically it's going to have 250,53 plus 360 n. So these two things must be together, and then you must have n, which is an element of real numbers. Okay, so the most important thing here to remember is that you must just change this sign to be cos, so that you can be able to use what we refer to here as what? As a k method. Okay, so we are done. Now let's look at 6.4 and see what we get. All right, so the first one is given x. So you are given two things here. Okay, let's quickly write things down. Write down what we are given. We are given x plus 1 over x, and then they say this is equal to 3 cos a, and then they are giving us that x squared plus 1 over x squared is equal to 2. Okay, they are saying we must determine, we are given this, and then we must determine the value of cos 2a without using a calculator. Right, so what are we going to do here? We're going to play around with this, and then we end up with cos 2a somehow, and then we'll see when we end up with. Okay, so let's quickly just take this one and work it out, and then see some other people can take different methods. It doesn't really matter as long as it holds mathematically. Okay, so when you simply take this thing, let's just swap it over to make it much easier. And then you will have 3 cos A, which is equal to x plus 1 over x. So if you square this thing somehow, so what are you going to get? When you square this, you're going to get 9 and then cos squared A on this side. Okay, and then this side you're going to get what? You're going to get x plus 1 over x multiplied by x plus 1 over x. Okay, so when you multiply this, you use a FOIL method, you remember? So x times x is going to be x squared, and then x times this is going to be plus x over x, and then this times this is going to be plus what? Plus x over x, and then this times this one will then be 1 over x squared. Can you see that? There's no like 10 for x squared, so we keep it as it is. So it's x squared, and then guys, x over x is 1, so it's 1 plus 1. So you'll end up having what? 1 so plus 1, and then plus this other one. 1 plus 1 is 2, so we're going to have plus 2. Okay, and then so this was plus, and then you have plus 1 over x squared. Can you see that? And then when you rearrange this thing, you then get x squared plus 1 over x squared plus 2. Can you see? And then this is same, and then on the other side you bring this down, and then you have 9 cos squared. Right? Guys, remember you were told that x squared plus 1 over x squared is equal to 2. So you will end up with 2 plus 2, which is what? Which is 4. Right? So you end up writing 4 here. So you've got 9 cos squared A, which is equal to 4. Right? Alright, so when you divide by 9, you want cos to be alone, cos squared A to be alone. So you divide by 9 here, you divide by 9, and this cancel this one, you end up with cos squared A is equal to 4 over 9. Alright, now remember guys, we are looking for what? We are looking for cos 2A. Okay, so we know that we can relate cos 2A with something that has to do with cos squared A. And how do we do that? We're going to look at our formula. Okay, when you look at our formula, you can see that cos 2 alpha is equal to 2 cos squared alpha minus 1. Okay, so in this case you'll have what? Let's just write it on the side. You've got, okay, let's write it here. Cos 2A is equal to what? Is equal to 2 cos squared A minus 1. Okay, right? So you must just take this to this side. Can you see that? When you take this, okay, let's just put it on a box so that it won't be part of this. So you end up with when you take this to the side, you end up with cos 2A plus 1 is equal to 2 cos squared A. Can you see that? So you then in the place of cos squared A, you then put what? This one. You will then say cos 2A plus 1 is equal to what? Is equal to 4 over 3. So 4 over 9. And then you take this one to this side. You're going to have cos 2a, which is equal to 4 over 9 minus 1. Okay, so 4 over 9 minus 1, you can just leave it like this, or you can actually take it further. So how are you going to take it further? Now people, can you see? It looks like we are confusing ourselves. Okay, we are making mistakes once again. Let's just scratch it like this. Okay, let's just take it like this. We've got cos 2a that we know, which is equal to 2. Sorry for that mistake, by the way. Cos 2a, which is equal to 2 cos squared a minus 1. Alright? Now, we already have cos squared a, which is 4 over 9. So in a place of cos a, we must just put 4 over 9. So because of that, we'll end up having something like this. Cos 2a is equal to nothing other than 2, and then in a place of cos squared a, you put this 4 over 9, and then you say minus 1. Can you see that? And then 2 times 4, that is 8 over 9 minus 1, and then 8 over 9 minus 1, we know from logic that what is that? That is nothing other than minus 1 over 2. Okay, is equal to minus 1 over 9. You can actually do it on the side somewhere. You will see that it will end up being something like this. Okay, so that is what we end up with, 6.4. So we've got our cos 2a. It is nothing other than 1 over minus 1 over 9. Right? Okay, let's quickly do the last question. That is question 7. All right, so the first question in question 7, okay, there is this statement. You can actually go and read it, and then let's quickly go to question number 7.1. So question 7. So 7.1, they say show that QS is equal to this. Okay, so where is QS? QS is equal to, they say it is equal to 3R. Okay, so how can you find QS? Okay, notice that this is a right angle triangle. Now when you have a right angle triangle, then you can apply cosine theta, and then the angle that we have here is 30 degrees, and then you've got opposite, and then the QS is this part which is adjacent. Now opposite over adjacent, that is tan. So you've got tan of that angle that is 30 degrees, which is equal to what? Which is equal to opposite, which is root 3r over what? Over adjacent. Over adjacent. Adjacent is what? Is QS that you're looking for, right? And then when you are here, you know you can cross multiply, and you can end up with QS tan 30 degrees is equal to what? Is equal to root 3r. Okay, and then divide by tan 30 both side, then you end up with QS is equal to root 3, and then you've got this r outside, divided by tan 30 degrees. Can you see that? And then this is same as root 3, and then you've got this r, and then what is tan 30? Tan 30 is 1 over root 3. Okay, and then we know that if we've got a number divided by a fraction, it flips over, then you'll end up having root 3 times r times root 3, and then square root of 3 times square root of 3, you will end up having 3r. So therefore QS is equal to r. Makes sense? All right. Now, let's look at 7.2. 7.2. 7.2, what are they looking for? They are looking for R, which is the area of the flower garden. And then they are saying we must put it in terms of R. So how do we go about doing that? Now, ladies and gentlemen, personalities, remember that the flower garden that they are talking about here is what? Is this part. Can you see? So there is, so when you are moving here from the center, the distance from here to here is 3r, and the distance from here to here is r. So if you want the area of this part of flower garden, then it is equal to the outer area minus the inner area. Okay, now what is the outer area? Outer area is pi, and then the r there is what? It's qs, which is 3r. So it's 3r squared, and then minus the inner area. Inner area is what? It's just the normal circle with radius r, so it's pi r squared. So this is 9 pi r squared minus pi r squared, and then you end up with 8 pi r squared. Okay, unit, whatever unit is, that is the inner area of the area of the flower garden, right? And then now let's look at 7.3. 7.3, and then they want us to show that rs is what? Is r, whatever it is, and then there's 10 minus 6 cos 2x. Now, how do we go about and show that? Now, where is rs? Can you see? This is r, this is s. Okay, so we've got this r, we've got this s. So what we are going to do, we're going to say rs squared. Okay, so we're going to say r squared, so that's r squared is going to lead us to this r. But what we must note here is that we want to include 2x somehow. So 2x is this angle, so we're going to use, so we've got two sides, and then we've got an angle that is included. Okay, so we're going to use what? We're going to use cos rule. So when we use cos rule, we're going to say rs squared is equal to nothing other than, it's going to be nothing other than 3r squared, which is this side, right, plus, and we've got another side which is r squared, and then minus 2, and then we've got 3r, and then times r, and then we've got cos what? Cos 2x. And then obviously this will give us 9 r squared plus r squared, and then minus what? Minus 6 r squared cos 2x, and then this will then give us 9r squared plus r squared is going to give us 10r squared, and then 10r squared minus 6r squared cos 2x. Can you see? And then can you see there is r squared, which is a common factor. So we're going to have r squared, and then we're going to have 10 minus 6 cos 2x. And then all of this, guys, is r s squared, right? So when you put square root both sides, we're going to end up with rs, which is equal to, when you put a square root here, we're going to remain with r. Can you see that? And then here, there's nothing that we can do here. Just keep it like this, 10 minus 6 cos 2x, which is exactly what you have here, right? So this is basically what you have. And then when you came to 7.4, and then they say you've got r, which is equal to 10 meters, and then x, which is equal to 56 degrees. They say now calculate rs. You already have a formula for rs. So what do? You will then say rs is equal to, in the place of r, you put 10, and then square root of, and this 10 minus 6, and then cos 2, and then in the place of x we put 56 degrees, and then you then put this in a calculator. And then when you put this in a calculator, what do you get? You will get 34,9. Where is my calculator? It's 99,9966, and then it's continuous, and then this is approximately 35 what? 35. Okay, what was the unit for this one? Was there any units? Okay, there was no unit. So if there's no unit, you just say 35 what? 35 units. Okay, if there was meter or centimeter or whatever, then you would have seen. Okay, but here there is no unit. Let's see, is there any unit? No, there is definitely no unit. So you just keep it like this. You say unit, and then you leave it like that. All right, ladies and gentlemen, this was November 2020 paper, and then only the parts that deals with what? That deals with trigonometry. Okay, so thank you very much, guys. As you can see, this was quite hectic. So if there are any mistakes that I couldn't be able to, oh, they say, sorry, can you see here? They are saying meters. Okay, so because it's meters, so you can also say meters. Write it as they wrote it. Okay, write it nicely. So it's approximately 35 meters. Okay, I do see the units now. I couldn't see it earlier. Now I see it. Okay, so ladies and gentlemen, personalities, if there are any mistakes that I made here, please feel free to actually let me know about them. Okay, so that I can be able to correct them. And then if there's something that you want to ask regarding what I've explained here, you can feel free as well to pop me a question so that I can answer you. But also, if there is any comment that you want to make regarding this, make sure that you give me that comment. Ladies and gentlemen, personalities, thank you very much for tuning in. This is November 2020 paper 2, the parts of trigonometry. And enjoy and have a lovely day, and goodbye.